Finally, let's look at functions described by tables. Much like graphs, tables are a very common way to display data when a formula might not exist. Tables that define a relationship between two variables will either have two rows or two columns. It is standard for the first row or the first column to be the input variable and the second row or the second column to be the output variable. In Table 1, the input is the time t in seconds, and the output is the position x in meters. In Table 2, the input is the volume in liters, and the output is the pressure in atmospheres. It would be pretty unusual for a table to define a relationship that isn't a function, because remember, a function is a relationship where every input has exactly one output. What would it look like for a table to not define a function? If we establish that the first column is the input, then in order for the table to have an input with multiple outputs, we'd have to either have a repeated value or two values in the same cell of the table. In Table 3, there are two rows with 15 in the first column, meaning two rows corresponding to the same input, 15. The entries in the second column are different, 1.6 and 2.0. So this table would indicate that the input, 15, has two different outputs, 1.6 and 2.0. So it isn't a function. In Table 4, the column for the input 2 has two numbers in the second row, 5 and 9. This shows that the input 2 has two outputs, so it also wouldn't be a function. To evaluate a function using a table, simply find the input value in the first row or column, depending on how the table is oriented, and see what output value goes with it. To solve using a table, find the output value in either the second row or second column, keeping in mind that an output may be repeated, and then find the inputs that go with it. For an example, we're going to use the table to answer the following. We're going to evaluate x of 1, solve x of t equals 5, evaluate x of negative 1, and solve x of t equals negative 5. To evaluate x of 1, the input, the number inside the parentheses, is 1. So we're looking for t equals 1 in the table, which we can find in our third column. The value directly below this is 0, which is x of 1. It may seem a little weird having x as the output variable, but this is very common in physics and engineering, where the input variable is almost always time. To solve x of t equals 5, we are now trying to figure out which inputs result in the output 5. So we look for 5 in the second row. There are two 5s, one in the second column and one in the fourth column. The values above them are 0 and 2. So x of 0 equals 5 and x of 2 equals 5, making the solutions to the equation t equals 0 and t equals 2. To evaluate x of negative 1, we should be looking for negative 1 in the first row, but there isn't a negative 1. Based on only the information in this table, without trying to do any extrapolation, we cannot answer this question. So we can either say that x of negative 1 is undefined, or x of negative 1 does not exist. Similarly, when we try to solve x of t equals negative 5, we would need to find negative 5 in the second row, but it isn't there. So we say the equation has no solutions. Remember, there's a big difference between evaluating and solving. We only say no solutions when solving an equation, never when evaluating an expression.